No. So in AC currents, we have we have DC, and we have AC. DC means what? Direct current. DC means direct current and AC means alternating current. AC means alternating current. Okay. Now, so in DC, the symbol is what? We get like this. Okay, this is DC and this is AC. Clear? Now, when we speak about AC current, we are not, see, this is the wall outlet, the plug, whatever it is. But we are not going to speak about that current. Actually, there is a thing called oscillator. Okay. Oscillator or frequency generator. Okay. You have one component called frequency oscillator or frequency generator. Okay. Frequency generator. Clear? Oscillator or frequency generator. Now, so that will have a panel like this. Now it has a time and it has a voltage and time. Okay, and there will be two pins, output pins. Okay, one positive, one negative, like this, or red and black, something like that. So what happens is here when we decrease the time, frequency will increase. That already you know, because they are inversely proportional to each other. Frequency and time both are inversely proportional to each other. Okay, so now frequency, what is oscillator? Oscillator means it produces oscillations. Okay, it produces oscillations or vibrations. Okay, it produces oscillations or vibrations. That instrument is known as an oscillator. Okay, that is known as oscillator. Okay, now for frequency, so what happens? It converts. What is oscillator? It converts DC to AC signals. DC to AC signals, and we have rectifier. What is a rectifier? In semiconductor we studied, no? What is it? DC to rectifier. We convert AC to DC. Instrument which converts AC to DC is known as rectifier. Okay. Instrument which converts AC to DC is known as okay. Now, so oscillator produces oscillators. It produces oscillations or vibrations. Okay, are you there? Are you able to understand? Yes. Ashas, are you there in the meeting?
Yes, sir.
No one is replying.
Yes,
okay.
sir.
Okay. Now we have oscillator produces oscillations or vibrations. Okay, oscillation, other name is frequency generator. Now it converts what is the purpose of oscillator? It converts DC to AC signals, or rectifier means AC to DC. Okay, rectifier means AC to DC. Clear? Rectifier means AC to DC. Now here we have three components. We have resistor, capacitor, and inductor. Okay, so R is resistor. What is the purpose of resistor or function of resistor? What is the function of a resistor? Can you tell me quickly? What is the function of resistor? So resistor means opposes the flow of current, right? It opposes the flow of current. Okay, opposes the flow of current. Or we can also say drives. It drives the voltage towards itself. Okay. So what is capacitor? What is the function of capacitor? Function of capacitor is to store electrical energy. To store electrical energy in the form of electrical field. In the form of electrical field. Or one more function is what? It is used for filtering. Filtering means to block DC and allow AC to pass through it. AC to pass through it. Okay. And what is R? R is resistor. Okay. Sorry, inductor. What is the function of inductor? Inductor is to store magnetic energy. To store magnetic energy in the form of magnetic field. Okay. In the form of magnetic field. Clear? Is that clear?
Yes, sir.
Okay, please note down. We will go ahead. So we are going to discuss now what is there in this lesson. What happens when we connect resistor in AC, capacitor in AC, inductor in AC. These are the three circuits. Then what happens when resistor, capacitor, inductor, all these three are connected in series in circuit. Finish. These are only the four. Actually, we have only the LCR. But the problem is they are asking questions from L, C, and R, because if you remove those two, definitely it will become only resistor circuit or capacitor circuit or inductor circuit. So that is why don't think that okay, RLC is not there, so therefore will not read. Okay, to understand RLC, we need to study compulsory these three derivations. Okay, clear?
Yes, sir.
Yeah, okay. Please copy this. Quickly we'll go ahead now. One second. Phase difference. So first, what is phase? What is phase? Phase is phi. Okay. So how do you define phase? It describes the state of motion and direction of a particle. It describes the state of motion and direction of the particle. Okay, it describes the state of motion and direction of the particle. That is said to be phase. So now, yeah, okay. One second. Now, so it describes the state of motion and direction of particle, or we can also say angle made with its initial position. Angle made with its initial position. Okay. Angle made with its initial position. Okay. So now what happens here? This is the phase. Suppose. So suppose this is the angle. Okay. The particle is moving like this. It doesn't mean it is moving in a circle. It's moving on a like up and down. Okay. It's moving up and down like this. So when the particle is here, it will be here. When the particle is here, it is here. When the particle is here, it will be here. When the particle is here, it will be here. And when the particle is here, it will be here. Understood? So it is what? A, this is P. Okay. B, C, D, E, F, and G. Same. So what happens? This is B, this is C, this is D. Okay, this is not required also. Only E. Okay. So when the particle is at P, here it will be described here. So there's this angle is said to be phi. Phase angle, that is phi. Angle made with its initial position is said to be phase. Or phase is what? It describes the state of motion and direction of the particle. Now, is that clear, all of you? And units of phase is what? It is measured in radians, not degrees. It's measured in radians. Now here we have in phase. What is in phase? Ashas.
Sir, anyone is on site?
We have, yeah, your friend is here.
Sir, ask him, no?
In
phase.
Yeah. Yes, Aaron, he is asking you.
Yeah, Aaron, tell what is in phase?
Yeah.
It is a state of a human being to be in depression.
It is 0 degrees here. Okay. Angle between both the waves is 0 degrees. Okay. So that is said to be in phase. Okay. I'm writing here in phase. So it is equal to how much? 0 degrees. Okay. Next is what? Out of phase. Out of phase means angle between both of them is equal to how much? So here, this is out of phase. Okay. So here phase angle is how much? 180 degrees. Okay. Then next is what? Constant phase difference. Next is constant phase difference. Okay. So what is constant phase difference here? So here, this is the thing. So this angle is said to be constant phase. This is a leading or lagging of a wave. Okay. Okay. So angle here, if the angle is equal to how much here? If the angle is 0 degrees, they are in phase. If the angle between the two waves is 0 degrees, it is in phase. If the angle between them is 180 degrees, it is out of phase. Angle between them, one is leading and one is lagging. That is said to be constant phase difference. So I have given one example for in phase. What is that? I have given one example for in phase before. Huh?
Aaron, sir.
Yeah, marching. Very good. Like soldiers marching on the soldiers marching. Okay, so that is said to be. Okay, so that is said to be in phase. And out of phase means what? Ashas.
Out of phase?
Out of phase, I told you before. You remember?
Trying to remember, sir. 1 minute.
Out of phase means.
So is it the dog and that's some.
No. I told you want to go to the party and your dad says.
Yeah.
What happens?
Study for board exam.
Yeah. So your phase will change, right?
Yeah.
Completely out of phase. Okay, 180 degrees. Constant phase difference means leading or lagging of a wave. One is ahead and one is behind. Like sometimes it happens, right? On boating when we are talking. Yeah. Is it not? Like leading and lagging of a wave. Okay.
Yes, sir.
Is it clear, all of you? Is this clear?
Yes, sir.
Okay, please copy this one. Then quickly go to the resistor circuit now. Yes, sir. What is first? There are Kirchhoff two rules, right? First is junction rule. Second is loop rules. Junction rule says that current entering the junction is equal to current leaving the junction. The second rule is what? Potential difference. Sum of the potential differences in a circuit is equal to 0. Sum of the potential differences in a loop or in a circuit is 0. Is that clear? So that is the second rule. So what is that? According to that, if you go, then here we have E is equal to what? E is equal to IR. I into R. I is the current and R is the resistor. So what is that? So here we are writing V is equal to what? V is equal to Vm sin omega t. Okay. V equal to Vm sin omega t. Clear? V equal to Vm sin omega t. Now we substitute here this value. Okay. Vm sin omega t is equal to what? Vm sin omega t equal to IR. Okay. IR. So what is I? I is equal to what? Vm by R into sin omega t. Okay. I is equal to Vm by R into sin omega t. And I is equal to what? I is equal to Im sin omega t. I is equal to Im sin omega t. Clear? So I is equal to Im sin omega t. So therefore, so here what happened? Voltage and current both are in phase. Is that clear? Voltage and current both are in phase with each other. See once again, Here E is equal to IR. This potential difference equal to this one, and V is equal to this the input voltage. Input voltage is what? V is equal to Vm sin omega t. We are equating Vm sin omega t equal to IR. And now what is this actually? When you go to grade 11, okay, we have a equation for a wave. You know, y of x comma t. If you go remember this, y of x comma t is equal to a sine